Hello everyone. In today's video, we'll be going through GATE 2021 questions and methodology to solve the questions for biomedical subjects. If you are preparing for the GATE Biomedical Engineering exam, this video will help you to understand how to tackle these questions step by step. Let's begin with first question from GATE 2021. A novel biomaterial was tested for its tensile properties. The experiment was conducted using a cylindrical sample of this material, which was 10 centimeter long with 1 centimeter diameter. When a tensile force of 50 kilonewton was applied, this cylindrical sample elongated by 4 millimeter. Based on the experimental results described above and the tensile moduli of different tissues given in the table below, this biomaterial would be suitable replacement for what? That's the question. Here, they have given the four choices: bone, tendon, ligament, articular cartilage. And these tissues is having the different kinds of tensile modulus. For example, bone is having 5 to 20 gigapascals. Then tendon, it's having a zero point 0.5 to 1 gigapascals. Then ligament, it's having 20 to 400 megapascals. Then articular cartilage, it's having 3 to 10 megapascals. Okay, here we have to find normal material which was tested, which would be suitable for whether it may be bone tissues or tendon or ligament or articular cartilage based on the tensile modulus. So first we have to find the tensile modulus. We will see in next slide. To find a solution, to determine which tissue the biomaterial would be suitable replacement for, we need to calculate its tensile modulus based on the experimental results and compare it with the tensile moduli of different tissues. Okay. The first step is to be analyze the Young's modulus. Okay, we already know familiarly we know the formula for the Young's modulus. E is nothing but stress by strain, where the stress is nothing but a force per unit area. So stress equal to F by A. Then strain is relative elongation. Strain is nothing but del L by original length. Okay, L0. So what are the given parameters? So here in this problem they have given the force applied F equal to 50 kilonewton. So if you are converting into Newton, that will be converted as a 50,000 newtons. The initial length L0 equal to 10 centimeter. So to make the calculation easily, we are converting into it's the same unit. So here we are converting into meters. So 10 centimeter equal to 0.1 meter. Then elongation, which means how much elongation it's happened. Elongation del L, the change of the length, it's nothing but 4 mm. Okay, for calculation purpose, we are converting into the same unit. So that's nothing but 0.004 meter. So diameter of the cylindrical sample, small d, diameter of the cylindrical sample, that's diameter is nothing but 1 centimeter. You're going to be converted into meter, that's nothing but 0.01 meter. Okay, so first we have to calculate the cross-sectional area of the cylinder. For finding the area, so A equal to pi d by 2 whole square. Okay, so here the d is nothing but our diameter. So we are replacing the d with 0.01. Okay, so pi 0.01 divided by 2 whole square. So it is giving the value of 7.85 into 10 to the power of minus 5 square meter. Okay, so that is the area, cross-sectional area of the cylinder. Okay, the next we have to find the stress. The first thing we have to find the stress. So stress formula is nothing but force by area. So previously we found the area. So here F has given in the problem. So 50,000 newtons divided by 7.85 into number of minus 5 square meter. So which gives the 637 megapascals. The value of the stress is nothing but 637 megapascal. Next, we have to calculate the strain. Okay, so strain, the formula for to find the strain is nothing but del L by initial length, which is change of length divided by initial length. Okay, so this data we already have. So we are just applying the values to find the strain. Okay, so now we have uh, the stress and then strain. Both values have, just we are applying in the Young's modulus. Just we are applying Young's modulus to get our final value. Okay, so here we got the value of 50.9 gigapascals. Okay, that's the final value for our novel material Young's modulus. Okay, so now we have to check this Young's modulus where it will be matched with given problem. Okay, you can check our value is 15.9 gigapascals. Okay, now check whether it will be come with bone or tendon or ligament or articular cartilage. Okay, so based on the values, it comes under your bone. So which is the material, which is the novel material for tested with the tensile properties, it comes under the tissue of bone. So based on the solution, we can find, so this novel material is matched with bone. Okay, so like that we have to find other questions which is based on our mechanical properties. Okay, so basically based on the mechanical properties, they will ask many questions in the gate exams. For this type of questions, you always remember the stress by strain relations. Okay, if we know very well about the relation between the stress and then strain, we can easily solve this type of questions. Regularly in gate exams, minimum one or two questions will be coming uh, based on the stress by strain properties. Okay, so we have to understand very clearly about the stress by strain or Young's modulus concepts very clearly in our concepts to attend the gate exams. Moving on to the second question, as shown in figure, the water contact angles of surfaces A and B are theta A and theta B, okay, respectively. Based on the figure, which of the following statements given below is true? Okay, so we can see the diagram surface A, how the water molecule will be attached with the surfaces. Okay, so on surface B also. Here they have given the four choices. One is surface A is hydrophilic and surface B is hydrophobic. The second one B is surface A is hydrophobic and surface B is hydrophilic. Then C, answer C is both surfaces are hydrophilic. Answer D, option D is both surfaces are hydrophobic. So we have to find which is the answer is correct. Okay, so here they have given the two concepts, whether the water molecules are surface adjacent is there or not. So it can be categorized into two. So hydrophilic and then hydrophobic. So normally the hydrophilic is nothing but the water loving, while hydrophobic means water fearing. These terms describe how water interacts with the surfaces and molecules. Okay, so hydrophilic absorbs water, bonds with water on molecular level, dissolves easily in water. Okay, so like as examples, you can consider as glucose and self cleaning glass like that. Okay, but hydrophobic, it repels water, does not dissolve in water. Okay, so for examples, you can consider as a fatty acids and cholesterols like that. Okay, so from the explanation, you can easily understand from the diagram. So what is the answer? Hydrophilic is water loving, hydrophobic is water fearing. Okay, so if it is hydrophilic, it is a water loving, so it is absorbs to the surface. Okay, so if it is water fearing, then it is not absorbed to the surface, so it is opposite to the surface. Okay, so can read the now you can read the answers. Surface A is hydrophilic and surface B is hydrophobic. Here it made as absorbed all the things is observed, and here not observed. So the answer A is surface A is hydrophilic and surface B is hydrophobic. So you can find answer here. Yes, A. Answer A is correct choice. Okay. So surface A is hydrophilic and surface B is hydrophobic. So, okay. So like that, we have to analyze our questions based on the base reasons. Um, from that, we have to find. So what is the answer likely? Okay. Yes. Now here is the next question from GALE 2021. Okay. So which of the following may cause failure of bone implants? Okay. So from these four reasons, which may be caused to the failure for bone implants. Okay. The first one is stress shielding, reduction of bone density due to removal of typical stress from bone by a implant, aseptic loosening, loss of bond between bone and implant in the absence of an infection. And third one, threading fatigue, progressive deterioration of material by small scale rubbing. The last one, so passive integration, which is nothing but formation of direct interface between an implant and a bone without intervening soft tissues. Okay, these are the four choices to find the answer. Okay, so here first we have to understand um, what it says, the four choices. Then we can easily find the answer. Which options will may cause failure of bone implants. Okay, so first one is stress shielding. Okay, so what is stress shielding? Okay, so when a bone implant bears most of the mechanical load, the surrounding bone experiences reduced stress, okay, which leading to a loss of bone density. Okay, so it can be known as familiarly it can be known as a Wolff's law. Okay, so this can weaken the bone and potentially cause implant failure. This is the one reason. So it can make as our bone implants as failure. Okay, so this may be one answer. Okay, it may these options may be correct for our question. The next one, aseptic loosening. Aseptic loosening. Okay, so this occurs when the bond between the implant and bone is lost in the absence of infection. Okay, so often due to micromotion, wear particles, or poor initial fixation. So it may rise. So it is a common reason for long-term implant failure. Okay, so look like it's also the correct answer. Okay, so for our question, the third one, fretting fatigue. Okay, the fretting fatigue statement, this refers to material damage caused by repeated small-scale rubbing or motion at the implant interface, which can lead to cracks and eventual failure of the implant. Okay, this is also the correct reason for making a failure of the bone implants. The last one, so osseointegration. So this is the desired biological process. So where the bone integrates directly with the implant, providing stability and functionality. Okay, so it is beneficial for the success of implant and does not cause for failure. Okay, so from this we can easily understand three reasons, which means three options make the cause of failure for bone implants. Okay, other one, which means D is it is a positive thing. It's not make as a failure of bone implants. So we have to select A, B, C. So all the three answers are correct for this question. Okay, so like that they will ask many choices, maybe correct choices. So we have to identify very clearly which is the answer, which answer is correct, and what are the answers are correct. Okay, so like that we have to identify very clearly, and we have to mark uh, with damn sure. Here, option A is correct, and option B is correct, and option C is also correct. Okay, so we have to give the three options for this question. Only the D will be wrong. Okay, Yes, the next question. Here, yeah, they have given the question. I will read. A polymeric scaffold has been developed for cartilage tissue engineering to understand the biodegradability of the material. So this polymeric scaffold with a dry weight of 20 milligram is kept in a lysozyme solution for 7 days. At the end of the 7 days, the scaffold is freeze dried and the dry weight is measured to be 18 milligram. The degradation of the polymeric scaffold after 7 days is what percentage? So that's the question. We have to find the percentage of degradation of the polymeric scaffold. So here, so they are fabricating or they are developing one polymeric scaffold. Okay, so after drying or after this process, so it's having some of the degradation. Okay, so we have to find how much percentage it has degraded. Okay, so for this type of questions, first find the degradation by using this formula. Okay, so the degradation percentage of the polymeric scaffold can be calculated using this formula. So degradation percentage equal to initial weight of the sample, okay, then minus or subtracting the final weight, okay, so then divide by the so initial weight. Okay, so here applying this formula, we can find the how much of percentage it will be degraded. Okay, so here we know very clearly from the problem. So initial weight is 20 milligram. So when it is fabricated, so when it is developed, the initial weight is 20 milligram. The final weight, it may goes to 18 milligram, maybe degrade 18 milligram. So what is the percentage of degradation? That's the question we have to find. Okay, so degradation is nothing but so initial weight 20 minus the final weight 18 divided by 20. Okay, so that we can get the answer is 10 percentage. Okay, so we can get the answer is 10 percentage. The degradation of the polymeric scaffold after 7 days is 10 percentage. Okay, so like this we have to find this is a this is not your objective type question. This is you have to find the answer and give the answer in the answers page. Okay, so maybe this type of questions may be rise. Consequently, you can check it out. The mechanical proper based on the mechanical properties, surely one question will be rising for each and every year. Okay, so yes, with this we have covered all the questions from the GATE 2021. So make sure to practice this thoroughly as they cover important topics frequently tested in the GATE exams. If you found this solution helpful, so you can share with your friends also. So thank you so much for watching. Let me know in the comments which questions you found most challenging. So until next time, happy learning and best of luck with your exam preparations. Thank you all.